Since the introduction of social media, people have been able to connect with one another in an instant. While this leads to information quickly spreading amongst individuals and groups, it also leads to the swift spread of misinformation. This becomes especially significant when the majority of individuals use platforms like Twitter as their main news source. During the COVID-19 pandemic, the World Health Organization had to resurface a previously coined term, the infodemic. The main focus of this analysis is to determine which subgroups are more correlated with misinformational spikes.
For this study, we identified three main groups as influential social network nodes: health organizations, news outlets, and individuals. Accounts for the health organizations category were restricted to governmental and medical establishments. Right and left news outlets were identified based on a classification study from Pew Research Center. And within individuals, we identify right and left-wing political figures and 63 of the top 100 most followed celebrities on Twitter, excluding politicians and groups.
We hope to answer the question regarding which influences are more likely to spread misinformation or information. We adopt the framework of social network analysis, where these influential figures are viewed as social network nodes with information quickly disseminating along its many edges. Now, three methods of analysis are considered.
We use the Python libraries Pandas, NumPy, and Matplotlib to create timelines containing tweet frequency, engagement, and sentiment. Tweets were scraped using the Python scraping tool Twint. Relevant tweets were then extracted through substring searching, where we applied the following case-insensitive COVID-specific substrings.
Tweet frequency is used to see if there are direct correlations between subgroups and known false and real tweets.
Tweets classified as containing real or fake information were gathered from a number of open-source datasets. However, our initial exploratory analysis found inconsistencies in the timeline distribution across these sets. Thus, only tweets between March and May of 2020 are used. Twint and these datasets also provided access to the tweet's engagement metrics.
Engagement is a crucial factor in deciding which tweet is shown to its user base.
We only focus on average likes and retweets per tweet over time.
Finally, we investigated this from the perspective of sentiment.
The tweets were processed to remove hyperlinks, RTs, punctuation, special characters, and were also converted to lowercase. Using the Python library TextBlob, the processed tweets were scored on a polarity scale from -1 to 1, as well as 0 for neutral.
Based on the literature, findings were made regarding higher dissemination of information if the source tweet contains negative sentimental language. Studying this potential source of virality can allow us to determine an answer to the question of what sentimental language is typically associated with misinformation.
To measure the correlation between these three timelines, we use the Kendall rank correlation coefficient. This coefficient is a non-parametric hypothesis test that provides insight into the strength of dependence between two variables.
It doesn't require prior knowledge of the distributions, making it perfect to use in this case as we don't know the distributions of the timelines.
The significance of this coefficient was then determined using the two-sided Mann-Kendall significance test, where the p-value is twice the z statistic and having a null hypothesis being a KRCC of 0.
The KRCC for tweet frequency is interpreted as a correlation between a user's posts and the spread of fake or real news. For the engagement metrics, a high correlation indicates some similarity between two audience groups. Similarly, the KRCCs for sentiment frequency is interpreted as the dependence of sentiment on the spread and engagement of real or fake news. We created multiple frequency timelines from March 1st to May 25th, 2020. As you can see in this figure, they are separated into each category of influential Twitter groups. The last two plots on this figure represent the spread of fake and real news collected from open source datasets. The blue squiggly line represents the number of daily tweets made per day, while the lighter blue histograms are the same tweets binned every 3 days. The following two figures represent the engagement timeline plots, while this figure shows the tweet sentiment timeline plot. Specifically, the left figure shows the average daily likes timelines, the middle one shows the average retweet timelines, and the right one shows the frequency of negative, neutral, and positive tweets per day.
So using these timelines, the Kendall rank correlation coefficient, the Mann-Kendall significance test p-value are determined to evaluate the correlation between pairs of influential social network nodes and fake and real news.
Health organizations have a low negative correlation with fake news. The high p-value for fake news is expected as it indicates that there is a high probability of achieving the null hypothesis, that there is no correlation between health organizations and fake news. Looking at the engagement metrics, average likes and retweets both have a much higher correlation to real news compared to fake news.
With regards to sentiment frequency, health organizations have a low positive correlation with real tweets and a low negative correlation with fake tweets. However, these relationships were observed to have high p-values, indicating a high probability of no sentimental correlation. This low correlation suggests that sentiment is not a factor that drives this engagement. Positive and negative information from right and left news outlets have significant positive correlations with real news and insignificant correlations with fake news. On the other hand, real tweets have moderate correlations with left news outlets and insignificant correlations with right news outlets, suggesting that real tweets may pass on information from left news outlets while a false correlation is present with the right news outlets.
Looking at politically left-leaning news sources, the only statistically significant value is the relationship between left-leaning news and true tweet frequency. So, relative to fake news, real tweets are slightly more correlated to left-leaning news. The low correlations between both engagement metrics and tweet types suggests that right-wing groups have little influence on the spread of tweets.
For political right-wing individuals, it was found that real tweets have similar positive and negative sentiments over time. However, as right-wing political figures have little influence on the spread of tweets, this correlation with real tweets suggests the presence of a false correlation. In terms of engagement, positive tweets are negatively correlated with likes and retweets, while other sentiments have little significance.
Politically left-leaning individuals have a strong statistically significant correlation with real tweet frequencies and between likes, retweets, and both types of news. The overall preference for real tweets suggests that left-wing individuals may impact the spread of real news more than fake news.
Real tweets also share positive and negative sentiments over time. In contrast, fake tweets are also influenced by this group but have low sentimental motivations. Looking at engagement, positive tweets tend to have positive correlations, while negative tweets have negative correlations.
Celebrities have varying results across all three metrics. Altogether, the mismatch between results may be due to the different types of celebrities with different audiences included in this study.
No study is perfect, and so here we outline a number of limitations to be addressed in order to further this study. Currently, the engagement correlations for likes and retweets are not weighted. However, as retweets often contribute more to the spread of information compared to likes, future studies may look into weighting retweets exponentially, while likes can be weighted as a constant. Furthermore, the engagement data used is biased towards individuals who are active on social media. However, as the focus of the study is the spread of misinformation on social media, it makes sense to not account for the silent users. Furthermore, the authors of each dataset used varying methods of tweet classification, introducing some variances in how real and fake are classified. Additionally, sentiment analysis was done using a pre-trained model from Python library TextBlob. As the model was not Twitter-specific, it may not have scored Twitter-specific speech or slang appropriately. We also recognize that a low correlation with a high p-value cannot be used to reject the alternative hypothesis. Further comparisons using a null hypothesis where the KRCC is 1 must be done to reject the correlation.
In difficult times like the COVID-19 pandemic, it has become more important to be able to learn and identify ways that can reduce the spread of misinformation. Our research using KRCC and sentiment analysis showed that, first, as expected, health organizations have significant correlation with the spread of real news in all three engagement criteria. 2, we find that politically left individuals have significant correlation with the spread of real news in likes and retweets. 3, celebrities have a high drive for both real and fake news in likes and retweets. And 4, sentiment analysis shows that emotions are not a driving factor for the spread of misinformation. From the current results, we recommend that social media users retweet tweets from health organizations and contribute to the spread of real news instead of fake COVID news. Furthermore, we advise that users should refrain from retweeting COVID news from celebrities. And although our findings do find that politically left individuals seem to contribute more to the spread of real news, it is in comparison with their correlation with the spread of fake news. One should still be cautious when we press that button and decide to retweet. Last but not least, we would like to thank Mark Ebden for providing us with valuable advice and guidance on calculating statistics and significance testing. Furthermore, we would also like to thank the STEM Fellowship for this opportunity to learn more about data science and engage in confidential research.